Students, greetings. In this video lecture, we are going to discuss about error control, introduction and block coding techniques. In previous video lecture, we have discussed about the link layer addressing concept. In this video lecture, we are going to discuss about error control techniques. So before going to discuss about error control, we must know the responsibility of the data link layer. Already we know flow control, error control, access control. In these three control, in this video lecture, we are going to discuss about error control. Okay. So this error control topic we are going to discuss in unit 2. Okay, in unit 2, classroom discussion topic 14. Error detection and correction. Under this topic, we are going to discuss about introduction of error control and what is block coding. Okay. So before starting this video lecture, we must know that lecture outcome of this video. After listening to this video lecture, you as a student will be able to understand the error control in data link layer and be able to detect and correct the errors. If while transmit any data is corrupted or identified as the error, we are able to correct it. How we can correct it, that we will discuss in this video lecture. Okay. Data can be corrected during the transmission. Some causes is there, already we have discussed. So some application requires that error be detected and corrected. So if in case data is lost, how we can detect that the loss is there, how we can correct it, that loss. Okay. So in this video lecture, we are going to discuss what are the types of errors, what is meaning of redundancy, detection versus correction, forward error correction versus retransmission, coding, and modular arithmetic. So in types of error, there is a two types of error is there. One is single bit error, another one is the burst error. What is single bit error? Only one bit in the data unit has changed. For example, 10 bits are there. Okay. So 10 bits are there. If only one bit, for example, instead of 1, it is changed to 0. Or instead of 0, it is changed to 1. If any one of the bit is changed, that is considered as the single bit error. Okay. So see here in this data stream, initially the sender is sent this data streams like 00000010. Okay. But the receiver is received this data stream 00001010, but it is sending 00000010. But here it is received 1010. So this bit is changed. Because of that, we are identified that one bit is error. Consider the single bit error. Okay. Next one is the burst error. What is the burst error? That two or more bits in the data unit have changed. Okay. So initially is that if 5 bits are there, if any more than one bit change. Okay. So here 0 changed to 1. Here 0 changed to 1. So 2 bits are changed here. So if 2 bit or more than 2 bit is changed, that is considered the burst error. Okay, you just remember that. So in this example, you just see here the length of 8. Okay, so the length of bit burst error means where the error is happened. Okay, so initially error is happened here. Instead of 0, it is 1. Instead of 0, here 1. Instead of 0, here 1. Instead of 0, here 1. So these 4 bits are changed. So when we are considered that error in this particular block, okay, so these 8 bits have the error. So we can say that this error is considered the burst error. Okay. To detect or correct errors, we need to send extra bits with the data. Okay, if we are sending the data, so there is error is there or not, how we can identify? We will give some extra information. That information is considered as the redundant bit. Redundancy means adding the extra bit. Okay. The structure of encoder and decoder, how the message is transmitted in the encoder side. Okay, so this is encoder side. Sender is encoding that message. How it is message? It is the original message. The generator will generate some add extra bit with the message. Okay, so what is adding the extra bit? That is considered the redundancy. So adding extra bit with the message, that is considered the encoder, encoding the data. Then it will transmit with unreliable transmission. The data is received in the receiver side. Here the checker, here generator is there, generator is adding the extra bit. This checker is checking the data, it is received correct bits or not. If it is correct or not. If it is correct, it will read as a message, or otherwise it will be discarded. It will initiate the retransmission. Okay. So this process is considered the decoding. Okay. We concentrate on black codes. Okay. So what is that? We concentrate on black codes. We leave convolutional codes to advanced text. There is a two types of coding is there for identifying the error. There is a black codes and convolutional codes. So convolutional code is little advanced techniques. In this particular subject, we only covers black coding. In modular n arithmetic, we use only integers in the ranges 0 to n minus 1 inclusive. Okay, so in for identifying the errors, we are going to use modular n arithmetic. So how we can do it? So modular n arithmetic normally using XOR operations. Okay, so XORing single bits and two words. How we can do that XOR? XOR means both the bits are same, then result is 0. Okay, both the bits are same, the result is 0. Both the bits are vary, the results are 1. Okay, so you just remind this XOR operation. Both the values are 0, the result is 0. Both the values are different, the values are 1. Okay. So here these two words they are given 10110, okay, 10110 and 11100. So how we can perform the XORing operations? So after putting this, you can apply the bitwise. First 00, same bit, answer is 0. It is a different bit, answer is 1. So it is the same bit, answer is 0. It is a different bit, so answer is 1. So it is the same bit, answer is 0. So this is how to apply the XORing method I explained here. What is black coding? While we are discussing about the digital to digital transmission, we discussed about line coding, block coding, and scrambling. So black coding means some block we are used to for identifying errors. Okay. So in the block coding, we divide our message into blocks. Okay. So what we have to do, the entire message will be split into blocks. Okay. So how many blocks? It may be a number of blocks according to our protocol. Okay. So that is considered as the data words. Whatever we are splitting into blocks, no, that is considered as the data words. We add R redundant bits. Okay, so extra bits we are going to add. That is how many bits means R. So total number of bits, that is n equal to k plus R. K is the number of blocks. R is the redundancy bit. So total number is there now, that is considered as n. So this is considered as the code word. Okay, this n is considered as the code word. In this lecture, we are going to discuss what is error detection, how to correct the errors, what is hamming distance, minimum hamming distance. We are going to discuss. So initially, in this diagrammatic representation, initially the message is there. The message will be split into number of k bits. So it is considered as the data words. After adding extra bits, okay, k plus r, okay, k plus r redundancy bit, that is considered as the n bits. So that's why here it is the size, but it is adding extra size here and here. So how it is happened? Because adding the extra bits. Okay. So this N blocks are considered as the code words. So example, we know that already 4 binary, 5 binary, 4B by 5B block coding techniques. What is the meaning of that? 4 binary values are there. We are adding extra 1 bit. The N value is 5. Okay. So each, if you are adding like that, what is the meaning of that? 2 power k equal to 16 data words. Then 2 power n equal to 32 code words. Okay. So k is 4 and n equal to 5. So if 16 data words is there means 32 code words we can use for transmit the 4-bit data. Error detection. What is error detection? So enough redundancy is added to the detect on errors. So what is the use of redundancy? Finding the error. Okay. So the receiver knows on error occurred but does not know which bit is on error. Okay. So we don't know which bit is error. We know some error is there. That is considered as the error detection. Okay. Has less overhead than error correction. We don't want to think about where the error is there, how to correct it like that. Simply the pattern is not matching. Simply we can say there is a error. Okay. So how to use this? Again, the data words are there. That is a k bits. Generator is adding the extra bit, r bit. So k plus r will be considered as the code word. Then that is the n bits will be transmitted with unreliable transmission. Here the receiver is receiving n bits. Finally, the checker will check that extract that k data, like it's removing the r. Then the proper output is came, that is the data word. If in case any error is there, that will be discarded. Okay, so there is no correction, only detect the error. If the error is detected, means simply we can discard it. So simple examples how they are using there here. If in case data word is two words 00011011. Okay, so two data. If the two data bits are used, then we are going is add with the extra bits. How we can add the extra bit? For in this example, so they are using the XOR operations. Okay, so 00. So both the inputs are 0 means answer is 0. That 0 is added. Here also 1 1. Both the inputs are same, so they are adding with 0. But here these two are inputs are varied, so they are adding 1. Okay. So this is the code word. According to that, data will be transmitted if data bit is 2. Okay. And error detecting code can detect only the types of error for which it is designed. Other types of errors may remain undetected. Okay. The structure of encode and decode in error corrections. What they will do? There in the previous diagram we are seeing, checker will check if there is no problem means that will be extract the data and data will be there. But in case if the data error is there means that is rejected, discarded is there in the previous diagram. But here in correction, the data won't be rejected, but it will be corrected, then it will converted to the data words. That's the main difference between error correction and detection. For correction, they are using different codes. For this table may be used for identifying the error. If in case caused there, then it will be verified. Okay. So sample questions I posted for your better understanding. How to detect the burst error? What is the burst error? More than 1 bit error is considered the burst error. How you can detect it? If the matching, when the detect some difference 1001, so if the receiver signal is 1001001, like that means what is the pattern matching? So this is okay, this is okay, but here not matched, here not matched, here not matched. So we can say this is a burst error. Okay. Mention the use of block coding in error control. So error control we are using for redundancy options. Okay. So what is the redundancy? What is meaning of redundancy? Adding the extra bit. Okay. So adding extra bit. How we can add the extra bits? Using the block coding techniques. Okay. So that's why we are using block coding in the error correction. So now we are in the end of this lecture. After listening to this video lecture, we are revisited this lecture outcome. So now you will be able to understand the error control, the data link layer. Okay, in data link layer, what is error control? What are the types of error is there? And how to identify the single bit error and burst error? And what method we are used for identifying and correcting the errors that we are discussed. Okay. So thank you very much for listening this video. The next video, I will continue with this error detection techniques using cyclic codes. Thank you very much.